Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of 2.5D machining operations in order to mill this entire part. If we take a look at the part itself, you'll note that it has many different types of features on it. First, we have deep pockets that have to be milled out. We have holes that have to be milled out or drilled out. We have this slot around the part itself that we can use our T-slot operation to mill that out. And you can also see that we have some Indexial operations that have to be done in the part. For example, these slots around the part over here. And from this side, we also have these holes that have to be drilled out. In addition, we also have the second side of the part where we have to have this pocket milled out as well. So we'll also be showing, besides the milling of the part itself, the different options we have for milling, we'll also show the different way we can set this up in SolidCAM with different types of fixtures as well. Now, let's first take a look at our Coordinate System Manager. If I were to open up the Coordinate System Manager, you can see I have created coordinate systems for every single one of those positions, whether it be position 1, position 2, every single side has a position defined to it. In addition to that, since I have to machine the second side here as well, I have also Mach 2 for holding it in a different fixture on this side. Now, as for my holding fixtures, I've used the configuration option inside of SolidWorks in order to have my different fixtures on the part itself. If I were to go into my configuration manager of SolidWorks, you can see I have 3 different configurations. One is the default, the way the part itself is right now. I have it with the stock, showing me the part with the stock and the first fixture. And I also have Fixture 2, showing me the part, how it's going to be held in the second fixture as well. And of course, as I said before, I also have the default option, which is just the part the way it originally came, and the way which will make it sometimes easier for me to work on as I'm creating my operations. Now, as far as the setup goes, I've defined my fixtures inside my setup, and I have 2 different setups on this part. I have setup over here, the very first setup, and for my second Mach position, I have my second setup down over here. If we take a look at my first setup, you can see that we have our clamping fixture, and if I want to take a preview of my clamping fixture, all I have to do is click on preview over here, and you can see the actual fixture that I have over here. You can also see that I've set the height of my fixture and my part so that we can see this well inside our machine simulation. Now, in addition, I also have my second setup. If we take a look at my second setup, we also have a preview of the part, and as you can see, we can see now our second fixture as well. And this also is set up exactly to where I want to have it sit on my machine during my machine simulation. Now, the first operation that I've done is face mill. This was used to take off the excess material that I have on top over here. If I were to open up the operation, you can see that I'm using the option called face mill. The geometry, as shown over here, is the border around the stock itself. And this was chosen automatically when I did base geometry and I chose the option of my stock itself. The tool that I have is a 100 millimeter in diameter face mill. And I'll be going down a 0.5 millimeter just to take off the top. And the technology I'll be using is hatch, going back and forth on the part itself as shown over here in the diagram. You'll also note that throughout SolidCAM, every single operation and everything we do inside SolidCAM has a diagram showing us exactly what that option is. Going into a field also shows us what that field actually does. Let's take a look at the simulation itself. And you can see, as I'll do this one step at a time, the tool will go down across the part, back and forth in a hatch manner to mill out the entire face of this part. Next, what I'd like to do is a series of different eye machining operations. I like to eye machine this area on the outside, from here all the way down to the step, and as well from this step down to the bottom. I also want to eye machine this area over here, this surface inside over here, and this area inside over here as well. And of course, this large hole that I have over here, I also want to use eye machining to mill that out. Now, for this hole I have over here, and for this area that I have over here, I like to do a pre-drill operation that would allow me later on, when I do the eye machining operation, to go directly into those holes to mill out those areas with eye machining. So the first thing I've done here was actually create a drill operation. If I were to take a look at the drill operation itself, I just used the geometry of these two centers over here, the center over here and the center of this area over here. I've used a 20 millimeter drill going all the way down to the very bottom of the part. If we take a look at the simulation itself, you'll see that the tool goes in, drills out all the way to the bottom of each one of those areas. And that's something we'll be using later on. Now I'd actually like to start removing my massive material that I have around the part, whether it be on the outside, this area over here, or the inside. I like to use now my eye machining option to remove the material efficiently and quickly. The first area that I did was the outside as shown over here. Now, before I continue, let's just take a look first of all at some of the settings that I've done for this part even before I start my eye machining. If I go into my CAM part manager, you can see at the very bottom, this material is aluminum 6061, which is used very often in the aerospace industry. I'll also be working at a machining level of 6, and I've defined the machine that I'll be working on over here. Now, if we go into the operation itself, the geometry in this particular case is based on my outside stock as shown over here, and is defined as an open area, and you can see that by the fact that it's using the color of black to show that particular geometry. And my second geometry is the inside area over here going around the outside of the part. Take a look from the top and you can see exactly what I'm talking about. We have the outside geometry and the inside geometry over here, working between these two geometries. Next, I have my tool. In this particular case, I'll be using a 16 millimeter end mill. It's outside of my holder 95 millimeters and has a cutting length of 32 with 3 flutes. And I selected my tool. My levels in this particular case, I have my upper level at 0 and my lower level is at 75. 75 is actually up until this surface over here. In my technology wizard, you can see that we're working on machining level 6. And if I go into modified conditions, you'll see that we're working on turbo mode. This material and this machine allows us to work in such a mode, as this is a strong machine and the type of tool can definitely handle this type of a load with iMachining. In my technology, you can see that I'll be leaving 0.24 millimeters offset from the walls. And if we take a look now at our simulation of the part itself, you'll see that the tool goes down, starts its iMachining on the outside, going down the amount it has to go down each time, using the maximum that it can of the cutting length of the tool itself. Again, if we take a look at it at our host CAD, you can see that the tool is going down. You can actually see the tool path itself over here as well, how it's actually doing a morph spiral on the outside and then tricordial on the corners itself at the very, very end. And it goes down the amount of step that it needs to go down in this particular part. If we take a look at the data of this machine, you can see that this part was machined in 4.5 minutes. Now, in my next operation, I've also used iMachining, but this time I'll be doing a finish cut around the outside of the part itself. If I go into the operation itself, you see I'll be using iFinish. I have the same tool I had before, as this tool is also good for finishing. My levels exactly the way I had it before. And in my technology, you can see we're working on the iRest data option. Run my simulation. Again, you can see the tool going down, and each step is done all the way to the very bottom using a finish cut of iMachining. And this was done in just under 1.5 minutes around this entire part. Now I needed to complete the outside by milling down from this edge over here down to the very bottom over here. So for that, I've done another iMachining operation based on the first ones, just with different geometries and different levels. If I were to open up the operation itself and take a look at my geometry, you can see that I have my first chain again is the outside, and the second chain this time is around this area over here. If I go to my levels, you'll see again my levels this time is from upper level of -75, which is in this particular case this surface over here, and the pocket depth is until the very bottom of the part over there. Now I added, besides that, a delta depth of -1 millimeter to go 1 millimeter past this area over here, so it wouldn't leave a burr on this edge. My technology wizard is the exact same the way it was before, and if I run my simulation now, you'll see that my tool this time will go down, clean the outside, and let's run this all the way through now. You can see it's cleaning the outside using a morph spiral. Now when it gets to the corners, it actually does that tricordial cuts on the corners. This particular operation, by the way, took a total of just over 1 minute to do. Now my next operation, also using iMachining, I just did the finish cut just like I did the last time, the finish cut on the outside wall over here, but this time on this area over here. Just taking a quick look at the simulation of that particular operation, you can see that the tool will just go down and mill out around the part, finishing off that area itself. Now in my next operation, I wanted to mill out the inside pocket over here. If I were to just take a quick look at the tool path of this particular operation, you can see that it's milling out the entire inside of this part using the iMachining option. You can see the morph spiral tool path of the iMachining operation over here and finishing off the corners using the tricordial cuts. Let's take a quick look at this operation over here, because as I said before also, I created a drilled hole over here so I can go directly into that drilled hole. Now, if I were to take a look at the operation itself, you can see my geometry is a simple pocket geometry over here. Again, using the exact same tool I used before, and the levels going down to that particular step over there. My technology wizard, same as before. Now let's jump into our link. In our link, we have the option of using the general type of approach. In that particular case, it would have actually done a helical cut going down into the part itself, or we have pre-drilling. By pre-drilling, all I have to do is choose the option of pre-drilling and choose from the list of drill operations that I've done. And in this particular case, I only did one drill operation, shows me only one drill operation. And it also shows me the diameter that was created over there, which is essential for iMachining so that it knows exactly where to start its operation. If I were to run my simulation on the part itself, and I'll do this one step at a time, you'll see that my tool will go directly into that hole and start milling from inside that hole itself. It didn't have to do a helical cut to start milling out the machine. It went directly down to the very bottom, saving us a lot of time as far as machining goes with the iMachining. I'll run this now through the very end, and as you can see, it'll machine each step down to the very end, and then stepping down every single time through that hole that I've created before. In my next operation, all I did was just the finish cut for this, again using iMachining. Again, if we take a look at the simulation of this particular operation, you can see that the tool will actually just go in and finish off the part at each level, running it through the end, and as you can see, it got to the very bottom of the part itself. Now, in my next operations, I've continued now with the iMachining operations to mill out this pocket over here, and of course doing the finish cut with iMachining as well. And after doing that surface, I've done the actual hole in the middle, going down to where I need to get to in that hole, using the option of going through that drill hole, just as if I did in this particular operation where I milled out this pocket over here. And of course, we have the finish cut that I've done there as well. All of this milling of the outside and the inside pockets over here, every single one of them was done using the iMachining operation. Let me just run a quick simulation of these operations over here. You'll see that it does all of those areas itself, as shown over here. First the outside, going down every single step on the part itself. And let's take a look at the entire time for this part. As we see, the outside part will take about 4.5 minutes just for the roughing. Now it's doing the bottom edges over there, completing that area, as well as the finish cut for that area. Now working on the inside pocket over here. Again, working on each level. First, in this particular case, using the morph spiral to mill out the pockets, and then finishing off the corners using the tricordial cuts until it gets to the very bottom of the part, and then doing the finish cut. Then of course it does this pocket over here, and then this area over here. Now, the entire time for this entire part, from beginning to end of milling the surfaces rough and finish, took just over 13.5 minutes for this large block of aluminum. Next on this part, I'd like to show you exactly how we mill out this area over here. As you notice in this part, it has this slot going around the entire part, and the way I will mill this out is by using a T-slot operation. If we take a look at the T-slot operation, it works very similar in many aspects to our profile operations with some many advantages specifically made for these type of geometries that have to be done, working around the inside of the part. First of all, let's take a look at our geometry. Our geometry itself is going around the inside of this area over here, and you can see the line going on the inside of that particular slot. Next, we have the tool. In this particular case, the kind of tool we use is a slot mill tool, where we have the diameter, the actual cutting diameter of the tool, the arbor diameter, and another important parameter over here is the cutting length. By putting in the cutting length, it knows exactly how much to step down inside that slot itself, and we'll go further into that in a moment. Now we have our levels. I pick my levels directly from the part, having my upper level at this edge over here, at this surface over there, and my depth on this surface as shown over here. Now let's go into our technology. In the T-slot technology, you'll note that it does not have in any one of these areas how much to go down each time, our down step. Our down step is automatically calculated according to the cutting length of the actual tool itself. What we do have here, however, is something called cutting depth overlap. If I want, as it goes down, the tool to overlap a specific amount, say 1 millimeter overlap every single time it goes down, I'll just put the option of cutting depth overlap of 1 millimeter. Now note, we can also do a rough cut, and we can also do a finish cut. And in the rough cut and in the finish cut, we also have the option of cutting depth overlap, and as you can see, also clearly defined in our picture on the side. I'll just put in 1 millimeter over there. You can see we can also go from the middle to the bottom and then going back up, or directly from the top to the bottom, or bottom to top. We have all of these options are inside our T-slot. It was exactly how we want to work with inside the slot itself. If I have to go into my links, our links are exactly like we have in any profile operation, with the options of arc, normal, tangent, and all of them exactly the way our regular profile operation works. In this particular case, I want to have my lead in as an arc, and my lead out the same as my lead in. I chose 7 millimeters. This way I have enough room to go inside over here without worrying about this wall. If I were to take a look at the simulation itself, you'll see that the tool goes down to this area over here, works its way in with an arc, working its way around. In this particular case, starting its rough cut from the top going to the bottom, and then it completes its part doing the finish cut at the end. Now, let me just go back in here and make one little change. If I go into my technology, I'll change top to bottom to middle to bottom. If we take a look at our simulation this time, you'll see that this time our tool will go down and start in the middle of the slot as shown over here, and then it goes down and then works its way back up, completing that particular slot. And since I had it on finish, it did the finish cut as well on that slot. Next, I like to deal with these holes on the part itself. I have the holes over here, and I also have these holes down here. Now, these holes on the very bottom, I'm not going to deal with now. Instead, I'm going to deal with those when I flip the part so I can drill it from this side using a shorter drill. These holes, if we take a close look at them, we have a drilled hole, but this surface over here is actually a fillet on the edge over here, as well as a fillet on this edge over here. So first let me drill out these holes over here. And I've done that by using a simple drill operation, choosing these two holes over here to be drilled out. The tool that I use in this particular case is a specifically designed tool of 10 millimeters in diameter with an angle of 150 degrees with 3 flutes. This is a very sturdy tool that allows me to go actually into those holes without doing a spot drill in the beginning. And it'll give me a very exact hole as I drill it out. The height in this particular case, my depth, was working from the upper level of this surface over here, and the drill depth itself going to this surface over here. Now, in addition, I've also added a delta of -1 millimeter to go 1 millimeter past the bottom of that hole, and I want to have the full diameter of the tool to go to that particular level. If we take a look at our simulation, you'll see that we have our tool going in, drilling those 2 holes out exactly the way I wanted it. Next, I have to still deal with the fillets on these particular areas over here. Now, in this particular case, the fillets that are on this hole over here is the same as a fillet on this hole, and they're all on the same surface. So I've created another profile operation, creating the chains around the inside of those holes itself. And my tool in this particular case was of an end mill. However, I used a shape tool. The tool that I used as a shape tool was actually, if we take a close look at the tool itself, is that it has an internal radius over here, which match fillet that's on the part itself. My levels, I have my upper level over here, and my profile depth is how deep do I want to have my tool go down. Now, let's just go back to my tool itself. The value that I have inside my diameter of 8 millimeters represents the actual small diameter that I have over here itself. This is the actual diameter that I want to have to go up until this geometry. If I were to take a look now at my simulation, you'll see that the tool will go down. You can see the actual radius of the tool going down, milling out the radius, and doing the same inside over there as well. If I were to do this using my Solid Verify simulation, again, you'll see the tool going down, and I'll zoom into this area. The tool goes down, puts the radius on, making for a perfect fillet inside the part itself. And this is just by being able to use a shape tool for this particular operation. Now that I've completed doing everything I can from this particular side of the part, I like to work now on these areas over here, these slots over here, and then these holes over here. And this is done by using different positions in this particular and different positions on the part itself, used for Indexial machining. Now, the first operation that I did over here was actually working on this slot over here. To do this operation, I've actually used something called Toolbox, which has many different easy made operations to do specific shapes. For example, in this particular case, we have a typical shape of a slot that has to be milled out over here. If I were to go into the operation itself, you'll note the first thing was choosing my MAC position, in this particular case, MAC 1 position 3. If I were to go into my coordinate system, you can see that we're talking about this slot over here. And if we take a look at the geometry itself, you can see the actual geometry that I've chosen over there of the slot itself. Note, in my toolbox, I'm using the option of toolbox cycle, and we have several different options over here. In this particular case, I'm using the closed slot option for this part, where it shows me that my geometry has to be just this around here, and shows exactly how my tool is going to work inside from one edge to the other. The tool itself is a 10 millimeter end mill, and my levels is from my upper level over here, going down to a depth inside the part itself up until the depth over here. When I have it go a little further, just add in my delta area how much further I want it to go down. In my technology area, you'll see that all I have to do over here is just tell it how much I want to go step down each time. Now, note there's nothing else I really have to do over here. This is an automatic operation which works with its own type of technology. In this particular case, if we take a look using our HostCAD simulation, and we'll do this one step at a time, you'll see that the tool goes down, actually goes down at an angle into the part itself, keeps on going down at an angle, and at the very bottom, it does one straight cut and then finishes the part. So this slot was easily done by using the T-slot operation. My geometry in this particular case was the exact same geometry I had before. Now, in order to make it work past that area, up until this wall over here, all I did was go into my technology field and I did modify geometry. By choosing modify geometry to the geometry itself, moving it out 2.5 millimeters so that it will actually work on the wall itself instead of this area over here. So using the same geometry, I did not have to create a new geometry. I just worked up until that wall with the option of modify offset. If we take a look at the simulation of this particular operation, we'll see that the tool goes down and works exactly the way I want it up until that wall, and then leaving it for a finished cut as well. Now, since I have the exact same type of operation over here and over here on the part itself, I just did the exact same operations that I did here, just using different positions on the part itself, as shown over here, using that position over there, as well as this position over here, but using the exact same type of operations, and of course, with the geometries for those particular operations. Next, we needed to deal with the drilled holes that are over here. So again, I just used a different position on the part itself, and I used the drilling operations for this hole over here, those two holes over there, and this hole over here. If we take a look at the simulation for all of these holes over here, we'll see that the tool actually will go down exactly into those holes, drilling out and completing all of the holes over there. Now let's just take one little look at this particular hole over here. This particular hole is a tapped hole. So for my last operation in this hole, I've actually used the drilling operation with the option of tap. If I were to go into my tools, you'll see that I'm using a tap itself. And if I were to open up the tool, you'll see that I'll be using a tap that has a diameter of 6 millimeters with a pitch 1 thread per millimeter. In other words, an M6 hole has to be done over here. If I were to go into my technology, you can see that I automatically have the cycle of tap for this particular operation. Now let's run simulation on all of these operations that I've done so far on this first particular Mac position, the one that goes in the very first fixture that I have for this part. I'll run the simulation, and the simulation that I'll run this time will be machine simulation, so we can see exactly how it's going to look on the machine itself. Now we can see here the machine itself with the part mounted on the machine. Let's just get rid of the housing of the machine so it makes it a lot easier to on the table itself. And we'll start our operations from the very beginning. And as you can see, it did the face mill on top, then the eye machining on every single area that needed to be machined using the eye machining. Then doing the next area at the very bottom to complete that area as well. Doing that huge pocket on the inside until the very bottom of the part. Finishing off that pocket and then working on the next pocket over there. Next, we're going to start our T-slot around the part itself as shown over here. And now the machine is actually going to turn to start working on the slots as shown over here. Working on each slot with the Indexial machining for those areas as well as the holes over here. Now that I've completed the first side of the part, I have to do the second side. And for that, I have Mach 2, because I have to do this with a different holding fixture as shown over here. So the part now is flipped around on a new fixture. And if I were to go again, just to remind everyone, go into the setup of the machine, you can see that my fixture is defined as these areas over here with the clamps and the screws as well. Now, the first thing I wanted to do was actually remove the material that was left over here on top. If I were to go into the operation itself, I used an eye machining operation to get rid of the material that was left on top itself. Now, the material that was left on top, if we take a look at our simulation, was actually this area over here. So my geometry was actually made just to go around this area, clearing up this excess material over here. Running the simulation, you'll see that the eye machining works just on that area over there, cleaning it up very, very quickly. And my next operation, I also did an eye machining operation for this hole over here, as well as the following operation, which finished that hole. My next eye machining operation was to clean off the rest of the material on top over here. And again, if I were to look at my simulation of this particular operation, we can see the material that was left over for the operation itself. And you can see that it works exactly around, cleaning up all of that material that was on that particular surface. Now, for my next operation, I still had to mill out this pocket over here. So again, just as before, I used the eye machining operation to mill out that pocket over there as well. Taking a look at the tool path from the top view, you can see that it has the morphed spiral tool path as well as trapezoidal for the corners itself. Now, in addition to this eye machining operation that I needed for this pocket over here, we also still have these areas over here that I did not mill out yet. So for that, I've also used the option of eye machining, creating for this slot over here as well as for the slot on the other side, doing both a rough and finish operation for those slots as well. Now, to complete this part, we've done our drilling operations that were left. We have our drilling operation for these holes over here, and I've used two separate operations for it. The first one using a spot drill to be able to leave a little bit of a chamfer on the edge of the hole itself. And the next operation was finishing it off with a regular drill operation using a drill of 10 millimeters. Now let's take a look at the simulation from this operation over here up until the very end. And again, I'll use the simulation of machine simulation to show this directly on the machine itself. Now, as you can see the entire fixture on the machine as it's being held on the machine itself. And the machining itself being done together with the holders, the table, everything can be seen in the simulation over here. You can see exactly what's being done on the part and how everything is being milled out. And this is exactly how the machining will look on the machine itself. Exactly the way this simulation is showing this part. For more videos on SolidCAM Professor, please go to our website, www.solidcam.com, and look for the tab called SolidCAM Professor. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.